All right, cool. Thanks, everyone. Quick. So this talk is about how to build immutable infrastructure. Uh, out of all of the people who doesn't have like a DevOps or an SRE background, show of hands. Yeah. All right, cool. So okay, so some quick rules. Just one rule. Just stop me whenever you have questions. Right. A little bit about me. Everybody calls me GP. I have around 17 years of experience. I've been programming for a very long time. I've been a computer nerd from when I was 8. Um, we could not afford a computer when I was young. Uh, I had to go to my neighbor's house 1 hour every day. They'd let me use their computer. That's how I got started. Since then, I've been working on a bunch of stuff, backend for a very long time, front end for a very long time, and then platforms and distributed systems and all of this. Why I am doing this talk is at at a particular job, we used to run a huge cluster of around 600 to 1200 machines. It was an auto scaling group. It would come up, go down based on load, and we had to come up with a system where we wanted to have this. The main problem was uh, people would say, hey, it worked on my computer, but when I deployed it on the cluster, it did not work. So we had to figure out, and I'm sure most teams would have had this problem at some point in time, and that's what this whole technique solves. So this is, I'll talk a little bit about what immutable infrastructure is, who can actually benefit from this, when you should not use this, and then I'll show you also a practical example of a technique we developed that actually helped us scale this whole thing. Any questions so far? Okay, cool. What exactly is immutable infrastructure, and is it actually a problem today? Right. Uh, Quick thing is, one, the machine images are built once and deployed many times. The components are replaced, never modified. And then the key philosophy is cattle, not pets. You don't want to manage each of these machines by yourself, but rather they're a large group. They're all the same. It's a big group, and you don't want to SSH into machines. Quick background on this, if this is, it doesn't make sense. So this is primarily for workloads that run on, like say EC2 machines. This doesn't have to do anything with Docker. Most modern teams today, they have moved to Docker based workloads, or they'll probably just run out a KAS cluster that somebody else has managed. So this is not a problem for many small modern teams. um, so but who needs this though? Who's still using this, and why are we still even talking about this? Is there are many teams that still use non-containerized workloads for a bunch of reasons. One is, um, 25, there's a recent study, I've added a link to it, is 25% of the industry is still actually using non-Docker VM based workloads. This includes teams who have very strong audit compliance requirements. This includes teams where they have to use VMs because they're generally faster. Teams that are very sensitive to performance, they usually prefer VMs instead of Docker images. One of the things that's not on the slide is also this new crop of AI inference, AI agents, even AI training stuff that you have to run on custom hardware. Those teams could also benefit from this. So who needs this is teams that are again running non-containerized workloads, teams that do AI inference or model trainings on very specific hardware and a software stack, and then teams also running many servers. A lot of the times, people would end up spinning small servers for one-off tasks. Right? Somebody has to build some small reporting piece uh, piece of software, and then there's something that does alerts, etc. Again, this is for teams that cannot use, say, lambdas or Docker images for stuff. So this is for a specific set, but I hope you can take away some history lessons rather, right? This is how teams used to work before Docker was a thing, before serverless was a thing, um, and then why it matters. Uh, any questions so far? Please stop me if I'm going too fast or if this is too boring. Um, the business impact is reduced downtime from failed deploys. So when something goes wrong, because you have immutable infrastructure, because you know what's on a machine. So the idea is you write a piece of code and that tells you what's on that machine instead of having to SSH into it and then looking at version numbers, logs, etc. Right. So when you have that, it's easier, faster to replicate this issue and drill down to the root cause. Again, as a direct result, faster incident recovery. So you can come back from issues faster. Improved security posture. Again, a lot of the enterprise companies, large organizations, they do have very strict security guidelines. So if, say, OpenSSL has to be updated, it's much faster to do it because you have code that describes what is in the machine. So it's faster to just do the updates, send out a new image, people would start consuming it. Problems this solves is, again, it solves configuration drift. And this is a classic problem, number one problem that most teams face. um, what happens is a lot of the times when you use servers, you would install a bunch of stuff there, you would run it. After a while, people want different things. Maybe somebody wants a dependency upgrade, maybe somebody wants a native add-on installed. So people would SSH or maybe write a script, and then the image changes over time. Now it has a bunch of stuff that not everybody knows, understand. So one particular dependency might be now breaking something else in a future upgrade. So this slowly moves out, and now nobody knows what's running inside, right? So this is a standard problem that immutable infrastructure aims to solve. Complexity in rollbacks is also faster now. So something goes wrong. Now imagine you had SSH into a box and you installed a bunch of stuff and you saw that it was breaking. How do you go back? It's very difficult to do, especially imagine if you were installing a bunch of Python packages, right? There's no tree, there's no dependency tree. So something goes wrong, it's very difficult to go back to this. But when you have written code for it, when you have immutable infrastructure, it's much easier to do. Again, security patching becomes easy. Earlier, it's for all these reasons that I just described, it's pretty complex to do, but with this, it's much more easier. I will also talk about why this you might not need this, right? If you were a small scale team, you have a very small number of servers, even though they're separate servers, it's okay. You don't need this because this is some amount of work, right? Second, if you do not have a mature CI/CD system, if you do not have the automation discipline, you might not need this because, again, this is somewhat pretty complex. And then for high velocity teams where you are making changes every day or you are doing a lot of experimentation and things move fast, this would actually actively slow you down. So for teams like that and for infrastructure like that, you might not need this. Uh, I will just jump to a demo now. Any questions so far? All right, cool. Is this good? People in the back, can you see this? Awesome. Uh, and this is also good. Okay, so I'll quickly talk about what the code does. So um, what we do is we basically use three tools. I'm hoping you're reading this. Three tools mainly. You are, again, free to choose the tools of your choice. The takeaway here should be just the technique. Do not focus about the tools, do not worry about the syntax, none of that matters, just the whole concept itself. So one is Packer. Anybody used Packer before? Okay, no. So Packer is by the same team who built Terraform, if you heard of Terraform. It uses the same HCL language. Packer lets you build an image programmatically. So how you have people built AMIs before? Anybody who's built, right? So can you describe how teams usually build AMIs in from your experience? Right, but uh, how though? Like, do you have you do you, can you explain the process itself? Right. Right. So so how people would usually do that is you most publishers, most companies publish their base AMIs. So if you want Ubuntu, for example, Canonical will publish their AMIs. So usually what teams do is they spin up a new instance using that AMI and then go into the, I mean, SSH into the machine, install all of the things they want, change all of the things they want, and then go back to your AWS console and say, take a snapshot out of it, build an image out of it. So this is an entirely manual process, right? So imagine you were doing that in your team. Nobody else would actually know what's in the AMI. You would have to tell me, hey, I've installed Kafka 1.7 or whatever, right? But like, how was it installed? Nobody knows. There's no visibility into that, right? So that's one of the things that Packer aims to solve. So I'll quickly show you um, what Packer does. So this is basically what Packer code looks like. Again, don't worry about too much about the syntax. I'll quickly walk you through what this does. So um, line number 1, it uses a AWS Amazon EBS instance. What this does is the process that we just described, it does programmatically. So it will take if you see line number 14. Wait. Yeah, so line number 14, we are picking up the source image that says Ubuntu 22.4, and it comes from Canonical. We just look it up. We have this ID hard coded, but it says take the base Ubuntu 22.04 image from Canonical, and it basically has some tags. These are important. This is to know who's built the image, when was it built, etc. And then we just do build. So here what I do is I have a shell provisioner. I just update all of the packages. This is an example. So in this example, what we're going to do is we're just going to set up a base image with Nginx, and we're just going to deploy that. So this is installing Nginx, and then this is stopping Nginx. And this is one of the very um core ideas about this technique is you install all of the stuff you want, but you stop the services. I'll over the course of this demo, I'll explain why we stop stuff. But we install everything we need, and then we stop everything. That's pretty much it, actually. So let me quickly just run this. I just have some just scripts that handles all of the Packer stuff. Again, don't worry about that. And this will take some time. But what it does is now, let me quickly show you on the console. Right, I hope you can see this, but an Nginx builder is up. So, and you can see the console output from here. So we've spun up an instance we're now we've SSH'd into the box. We're going to install Nginx, like I said. Once Nginx is done, Packer will wait for the terminal for the instance to terminate, and then it will take an AMI out of it, and then it will wait for the AMI to become available, and then it will print its output and say, okay, job done. So what we've done is we fully automate the process of building an AMI image. So now when you say, hey, I have this new image ready, people can actually read your code and then can exactly say what's inside that box, what version, what's installed, everything. So they can tell you. It's very transparent and it's readily available and it's machine readable, so you can tell what's inside the box. This will take a while though, because AMI building is a little slow. Any questions so far, or would anybody like to know anything about what we've done so far? Cool. All right. So Nginx is done. So you can see, um, yeah. So you can see Nginx was installed. You can see that we have stopped the process. Verification is done. The service file was removed like we wanted. So now if you go back and I refresh, you can see that it was terminated. So meaning the job's done. Uh, the AMIs take a little while to become available. So you can see on the AMI screen, this is becoming ready. So this takes a few minutes. So stage 2 of this, now that the AMI is ready, stage 2 is Terraform. I show of hands, how many people have used Terraform? Okay, cool. So this is so what we do now with Terraform is we provision the infra we want from the AMI we just built. So while we wait for this, I'll get started on the Terraform. Again, do not worry too much about the syntax. This is just code to just bring up the image. You can see that, okay, so this is the image I'm bringing up, and I've looked up the uh, AMI ID using the tags I created. So there's no hard coding of the AMI. So when you build version 1 of your AMI, and then tomorrow you build version 2, you don't have to do anything. The code picks it up. So if you can see, it says it looks up AWS AMI. It looks up that this is I am the owner, meaning the same account has built the AMI, and we just say filter Nginx immutable star. So if you go back to the AMI, you can see that the AMI name is Nginx immutable, and I've added a timestamp. So this way you get to control what resources you provision fully programmatically. There's no one team saying, hey, this is the ID, go use it. And there's no copy paste. That's one of the key unlocks of this technique. Yes, I can show you here. Okay, so while the image is not ready, tags don't show up, but I can show you here. Yeah. So this way, you can then build tags for specific teams, and then you can fully automate the process. No sharing of values, right? So you so teams that usually do this, what they end up do is they end up building multiple versions of images, and then they build multiple images for multiple teams, right? And then for projects. So you could just set up all of this information in tags and then have it passed down to the Terraform, and then you could just provision infra for saying, let's say you want to build a cluster for a specific type of job, right? You could just use the tags and say bring up an ESG with this number for this tag. So you could just read AMIs just by using these tags. All right, so the image is ready. Okay, so now you should be able to see the tags, right? So step 2 is Terraform. Let me go back to this. So we just bring up an instance based on the data lookup we just did. Again, none of this is useful. So, and we also just set up an SSH key for the third step to be used. Again, this is not something you would do in production. Doesn't matter, it's a low level implementation detail. I'll just quickly do that. So let me go back to instances. Okay, and you can see that nothing's running, right? The builder is done. Now we're going to deploy the Nginx image itself, right? I'll just do. So this is just running Terraform with those variables set up. It'll just bring up the instance. This should be faster than Packer, but I guess just the network's slow though. Yeah, not great.
Instead of manually building, we are using the Terraform and
Yeah, yeah. So the main advantage is because this is all programmatic, you can go tell confidently that, hey, this is how the machine will behave, right? Because nobody else has SSH'd into it. Really, in production environments, you would never do this. I mean, you would do this, and then you would just you would not even have to generate SSH keys and save them locally. It's all on the cloud. Nobody has to do anything. If somebody asks what's on this machine, you could just make them read the code, right? So Terraform is also done. A new instance should be up. So you can see that the demo instance of Nginx is ready. It's initializing. The machine, once it boots up, what we'll do is we'll go access. I've set up a public IP for it. We'll just go access that, see that Nginx is not running, right? And then we'll do the third step, which I'll show you folks. And then you'll see that the hello world page is up, the basic Nginx welcome page. This will take a small amount of time. All right. So while we wait for this, I'll talk about the third step, which is Ansible. So what we do in Ansible in this technique is we only configure stuff and we start stuff. We never install anything. That's the single most important principle in this technique. So usually teams do use Ansible or Chef, Puppet, Composer, whatever to also install stuff traditionally. And it has its place, it can work, but the most important philosophy in immutable infrastructure is you never install stuff on the AMI. You only change stuff, you change some files, you start a service, you stop a service, you restart, things like that, but you never install stuff again. If somebody wants something else installed, then you build a second image. You take the first image as you build a hierarchy of images, right? You build a company wide base image that has the basic tool setup, JQ, whatever you need, S3CMD, whatever. And then you, just like how we used filters to build from the Ubuntu image, you build a hierarchy of images. Then you take the company base image and then install team specific stuff, project specific stuff. Uh, Let me quickly see. All right, so this is running. So you can see that this is not working. This is the public IP. It's not working. I'll quickly show you what Ansible is doing. All it does is just start Nginx. That's it. Okay, it's Ansible is about to start Nginx. Done. Now, same page. I refresh. Oops. I guess it'll take a while. Oh, I just had to do HTTP. Yes. So Nginx is done. That is all. Any questions?